Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have solved 4 problems on DFA construction, including designing a DFA for accepting the strings starting with a given substring, ending with a given substring, containing a given substring, and even based on length of a string. And now, in this lecture, that is problems on DFA set 2, we are going to solve few more varieties of problems on DFA construction. So let's get started. In this lecture also, we will solve total of 4 problems on deterministic finite automata. So here is our very first problem. Let's read it together. Design a transition diagram of a DFA that accepts all strings with exactly 2 zeros over the alphabet 0, 1. That means, in this question, you are required to design a transition diagram of a DFA that accepts all the strings made up of zeros and ones with exactly 2 zeros. That means the number of zeros in your strings should be exactly equal to 2, not less than 2, not greater than 2. So let's see our language. In this language, you can see every string contains exactly 2 zeros, not less than 2, not greater than 2. But it is to be noted that there is no restriction on the position of zeros. That means it is not necessary that both the zeros will come together. Zeros can come together and zeros in the string can be far apart also. Also, there is no restriction on the number of ones and the position of ones. So there can be no one, single one, 2 ones, 3 ones, and so on. So we can have 1 any number of times anywhere in our string. So let's start designing our DFA. This is the simplest string that we will consider while designing our DFA because 0, 0 is the smallest string and 0, 0 contains exactly 2 zeros, so it will be accepted by our DFA. So first of all, we will have our initial state. On processing the first symbol 0, we will reach an intermediate state, let's say Q1, and after processing the last 0, we will finally reach our accepting state, which is Q2, because now the string contains exactly 2 zeros. So these two states, that are Q0 and Q1, are rejecting the strings having less than 2 zeros. The state Q2 is accepting the strings having exactly 2 zeros. But what about the strings having greater than 2 zeros? So if I get one more zero after processing exactly 2 zeros, I will reach the dead state, that is Q5. Because now we have greater than 2 zeros. So we are reaching the dead state, that is Q5. So this is the basic transition diagram for our DFA. But it is still not a valid DFA. In order to make this transition diagram a valid DFA, we need to complete all the transitions for all the states. Q0, Q1, and Q2 have a transition for 0, but these states do not have a transition for input symbol 1. And I have just told you that in this question, there is no restriction on the number of ones and the position of ones. That means 1 can come anywhere any number of times. And that is why we will simply create a self loop of 1 on these 3 states. Now, if I talk about the state Q5, that is our dead state. So once I reach the dead state, on getting any symbol 0 or 1, I will still remain at dead state. So I can simply create a self loop of 0 and 1 over the dead state Q5. Now this is the valid DFA for the given problem. And now we can proceed to our second problem. This is the second problem. Let's read it together. Design a transition diagram of a DFA that accepts all strings with at least 2 zeros over the alphabet 0, 1. That means, in this question, you are required to draw a transition diagram of DFA that accepts all the strings made up of zeros and ones with at least 2 zeros. Now, at least 2 zeros means that the number of zeros should be greater than equal to 2. Number of zeros cannot be less than 2. So let's see our language. In this language, you can see every string has the number of zeros greater than or equal to 2. No string has number of zeros less than 2. Here we have 2 zeros, here we have 3 zeros, here we have 4 zeros and so on. So no string has number of zeros less than 2. Also, like the previous question, it is to be noted that there is no restriction on the position of zeros. Also, there is no restriction on the position of ones and the number of ones. So 1 can appear any number of times and anywhere in our string. So let's start designing our DFA. We will consider 00 as the simplest possible string because 00 is the smallest string and 00 is having at least 2 zeros. So first of all, we will have our initial state, that is Q0. On processing the input symbol 0, we will reach an intermediate state, that is Q1. On reading the last symbol, that is 0, we will reach our accepting state, that is Q2. So now our string has at least 2 zeros in it. Now we simply need to complete all the transitions for all the states. Q0 and Q1 have the transitions for 0, but they do not have a transition for 1. And I have already told you that there is no restriction on the number of ones and the position of ones. So we can simply have the self loop of 1 over these two states. Now if I talk about our accepting state, that is Q2, we can have any number of zeros because we already have 2 zeros, and according to the question, our DFA should accept all the strings having at least 2 zeros. So if more number of zeros come, we will remain at the accepting state because our string will be accepted. And if I talk about the transition for input symbol 1, that will also be the self loop because we can have any number of ones in the ending also. So we will simply create a self loop of symbols 0 and 1 over the state Q2. This is a complete DFA for problem number 2. Now we will proceed to our problem number 3. Design a transition diagram of a DFA that accepts all strings with at most 2 zeros over the alphabet 0, 1, which means you are required to draw a transition diagram of DFA that accepts all strings made up of zeros and ones having at most 2 zeros. Now, what is at most 2 zeros? At most 2 zeros means that the number of zeros should be less than or equal to 2. Number of zeros should not be greater than 2. So let's see our language. In this language, you can see every string has number of zeros less than or equal to 2. No string has number of zeros greater than 2. If I talk about this epsilon, which is our empty string, it has no symbols, neither 0 nor 1. That means the number of zeros is equal to 0, which is less than 2. That is why it is a valid string. Here we have a single 0. Here we have again no 0. Here we have 2 zeros. So basically in all the strings, we don't have number of zeros greater than 2. So all these are valid strings. Now we will simply design a DFA for these valid strings. First of all, we'll have our initial state, that is Q0. And in this case, you can see the initial state is the final state itself. Why? Because if there is no symbol, that will also be accepted. I have just told you in the empty string that empty string has no symbols, neither 0 nor 1. So number of zeros is equal to 0. That is less than 2. So it will be accepted. And if I have only 1 0, that will also be accepted. If I have 2 zeros, that will also be accepted. But if I have greater than 2 zeros, that means if I get one more 0, then I will reach the dead state, that is Q5. So the strings having greater than 2 zeros will not be accepted. Now we will simply complete the transitions for all the states. So Q0, Q1 and Q2 have the transitions for 0, but they do not have a transition for input symbol 1. Now exactly like the previous questions, here also we have no restriction on the number of ones. So 1 can come anywhere, any number of times. So we can simply create a self loop of 1 over these 3 states. Now if I talk about dead state, you don't have to worry about the transitions of dead state, because once we reach the dead state, we are trapped at the dead state. So if we get any other symbol from the set of input symbols, we will still remain at dead state. So we will simply create a self loop of symbols 0 and 1 over our dead state. So this is our deterministic finite automata, which will accept all the strings having at most 2 zeros over the alphabet 0, 1. Now we will proceed to our last question, that is question number 4. Design a transition diagram of a DFA that accepts the given language. L is equals to W belongs to 0, 1 asterisk such that second input of W is 0 and fourth input is 1. That means you are required to draw a transition diagram of DFA that will accept the following language. Now let's understand this language. Here it is written W belongs to 0, 1 asterisk, which means the string W can be any combination of 0 and 1. So our language will contain the strings made up of 0 and 1. Now let's see the second condition. Second input of W is 0 and fourth input is 1. So the second symbol of our string W should be 0 and the fourth symbol should be 1. So there are two restrictions on our string, that the second symbol should be 0 and fourth symbol should be 1. But there are no restrictions on the first symbol, third symbol, fifth symbol, sixth symbol, seventh symbol, and so on. Only there are two restrictions. So let's see the refined form of our language. In this language, you can see all the strings have second symbol as 0 and fourth symbol as 1. In this string, the second symbol is 0 and the fourth symbol is 1. The second symbol is 0 and the fourth symbol is 1, and so on. So let's start designing our DFA. We will have our initial state, that is Q0, and now we will process our very first symbol. As you can see, there is no restriction on the first symbol. So first symbol can be either 0 or 1. So on getting the first symbol, we can reach the next state, which is Q1. Now we will process the second symbol, and there is a restriction on the second symbol, which should be only 0. So if the second symbol is 0, then we will reach the next state. Now again, there is no restriction on the third symbol. So third symbol can also be either 0 or 1, and we will reach the state Q3. Again, there is a restriction on fourth symbol, which should only be 1. So if I get 1 as the fourth symbol, then I will reach Q4, which is our accepting state. Now we will simply complete the transitions for all the states. Q0 has both the transitions for 0 as well as 1. Q1 has a transition for 0, but doesn't have a transition for 1. And we already know, if the second symbol is 0, it is moving towards the accepting state. But if the second symbol is 1, it will reach the dead state, that is Q5. Because on getting 1 as the second symbol, our condition is failing. For the state Q2, we have both the transitions. For the state Q3, we have a transition for input symbol 1, but we don't have the transition for input symbol 0. And according to the question, if the fourth input is 1, then we reach the accepting state. But if the fourth symbol is 0, then we will reach the dead state, because on getting fourth symbol as 0, our condition is failing. Now once we reach the dead state, we don't need to worry about the transitions. So we will simply create a self loop of 0 and 1. And for the final state Q4, we have already got 0 as our second input and 1 as our fourth input. So it doesn't matter what comes after that. So we will simply have a self loop of 0, 1 over the state Q4. So this is a complete deterministic finite automata for the following language. And in this way, we have completed all the 4 problems on DFA. But still, there are few more exciting problems left to cover. So we will solve those problems in our next lecture. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.